When hockey players wind up to take a shot, they want to make sure that the stick in their hands is of the best quality, both in how durable it is, and how it improves their shot. Not only do they want the shot to go exactly where it is aiming, but don't want the stick to break while taking the shot. Previously field hockey sticks were made with wood, but now the advanced technology of carbon fiber has taken sporting goods to the next level of performance. Golf shafts, rackets, skis, snowboards, hockey sticks, fishing rods, and bicycles have all been advanced through lightweight and durable carbon fiber reinforcements. As a result, almost 100% manufacturing of hockey sticks now comprise of carbon fiber. The field hockey stick global market value estimated at $542.4 million in 2024, projected to reach $628.7 million by 2030. The current lecture briefly describes the manufacturing process for these sticks. Specific regional markets are in Europe, North America and Asia. In Europe, a significant market, with countries like the Netherlands, Germany, and England being strongholds of the sport. North America has a large market, with a strong presence in Canada and the United States. Asia has rapidly growing markets in countries like India, Pakistan, and Malaysia, where field hockey is a popular sport. Wood has been replaced by composite carbon during the last 2 decades for making field hockey sticks. Carbon fiber has been described as a game-changing material, and all performance indicators support this theory. Carbon fiber elevates sporting equipment, and pushes sport to the next level of performance. Bikers ride faster, golfers swing stronger, skiers have more control and versatility, and performance is improved at all levels. The sticks are usually made in 2 different pieces, the shaft, which is the long part that is held, and the blade. Pieces are fused together to create one continuous piece. Carbon fabric is made up of thousands of carbon threads combined with a plastic resin that gives the material strength and flexibility. While there are many steps to creating these new carbon hockey sticks, the whole process only takes about 2 hours from the first sheet of carbon fiber, to the logos and final layer of paint. Doubled-up sheets of carbon fabric impregnated with suitable resin are cut into pieces and rolled together, usually about 20 sheets, around a shaft-shaped mold. The worker must make sure that each sheet is pressed firmly and there are no bubbles in the shaft, or it will cause the stick to break when in use. While the shafts are being made, the blades are created simultaneously as well. The puck must be able to spring off the blade and create more velocity, while being lightweight. Curved shapes dictate the use of stick in shots or passing during the course of play. A hard shooting defense man will want a different curve than a sniper winger, but it all comes down to individual player preference. The temperature is very important, and the sticks are baked in compression chamber that is heated to about 300 degrees Fahrenheit for about 30 minutes to an hour. The shafts take their shapes as one strong, unbreakable bond of carbon fiber. Sticks are created with different flexes for different types of players. A bigger, stronger player will use a stiffer flex, while a smaller, weaker player will use a stick that flexes more. The sticks after demolding are a little rough, edges sanded down a bit, and then the stick is polished and primed for painting. The sticks are painted by hand depending on the brand and model. This usually takes many layers of paint and different colors. If the stick is meant to have a grip layer on the outside, it will be applied now as well. Field and ice hockey sticks after finishing and packing are shipped off to stores. The option of custom-made carbon fiber hockey sticks is more expensive, but to get a stick that fits your perfect specifications, it can definitely be worth it. Important web links related to Technology Education and Mentoring Center are flashed on the screen. More lectures introducing the manufacturing of daily use fiber reinforced composites products and items will be uploaded on our YouTube channel.